Students, welcome to my channel EEC. I am Dr. P. Suresh. In today's class, we are going to discuss regarding drawing of reactance diagram for the power system. Actually, if you take any power system, the power system is having some components like generator, transformer, transmission line, motor, etc. For all these components, it has its own reactance value. So those reactance values were calculated using a particular base, and also in order to make the calculation easier, all the parameters related to components are converted into per unit values. So those per unit values were calculated using some base. Now we are going to change the base of the power system, changing the base. Once the base is changed, the reactance values are also getting changed, because in order to find the per unit value, the formula for per unit is nothing but actual by base. When the base is changed, then the per unit is also getting changed. So how we can find the reactance values for the components when the base is changed, but the reactance values were calculated using some other bases. Now we are going to change the base. So we know that per unit value is nothing but actual by base. So there is a formula, actual by base. So per unit voltage, per unit power, similarly per unit impedance or per unit reactance. So for finding the per unit impedance or reactance, per unit impedance, that is denoted by Z per unit, which is equal to actual impedance by base impedance. So this is the formula to find the per unit value. So once the per unit value is calculated, it does not have any units. So when there is no unit for any parameter, the calculation part is very easy. So that is why we are converting into per unit values. So here we have some formulas in order to find the per unit values of the components. So if you take the generator, motor and transformer for calculating the per unit values or new per unit values for generator, motor, transformer, so this is the formula. So Z per unit is equal to Z per unit old in the sense the per unit values calculated using previous base. So that is, using previous base they calculated some Z values, impedance values. So that is called as Z per unit old. So using old value, we are going to find the new values. So Z per unit new is equal to Z per unit old multiplied by kVb old by kVb new. So old value of voltage by new value of voltage whole square multiplied by MVAB new. It is nothing but new value of power and old value of power. So using this formula, we can calculate the new per unit impedance values. So normally if you take the old one, old values are given in the problem. So the values which are given in the problem should be considered as old values. So from the old values, we are going to find the new values. So for generator, motor and transformer, so this is the formula. And also for transmission line, when there is a transmission line, the formula is changing. So for calculating the Z per unit value for the transmission line, Z per unit is equal to Z actual by Z base. Z actual by Z base. But Z base is to be calculated using the formula kVb square by MVAB. Z base is equal to kVb square by MVAB. So when it is substituted here, we can get the formula Z per unit is equal to Z actual into MVAB divided by kVb square. So this is the formula, right? Similarly, the power system will be having some transformers. For transformers, when there is a transformer, for transformers there is change in voltage from low voltage to high voltage or high voltage to low voltage. So whenever the power flows from low voltage to high voltage, so this is the formula. So kVb new value of voltage should be found. New value of voltage should be found. Whenever a transformer comes, then the new value of voltage should be calculated. So there is a formula kVb new is equal to kVb old multiplied by HT rating by LT rating. And similarly, when the power flows from high voltage to low voltage, then kVb new is equal to kVb old multiplied by LT rating by HT rating. So once the new values of voltages are calculated, then the new values should be substituted here. This is nothing but new value of voltage. So for finding the transmission line, when the transformer is connected in the transmission line, initially we have to calculate what is the new voltage. So the value of the formula depends upon how the transformer is connected, from low voltage to high voltage or high voltage to low voltage. So after finding kVb new, that kVb new should be substituted here, and then we can calculate what is the Z per unit for the transmission line. So these are the formula. Right. So using this formula, we will take a problem. So this is the given problem. For this, we are going to calculate what is the reactance value, per unit reactance values or per unit impedance values. So the problem given is the three-phase power and line-to-line voltage rating of electric power system is shown in the figure. So this is the figure. So this is the power system. So this power system is consisting of a generator and two transformers. T1 and T2 are the transformers. These two transformers are connected with the transmission line. So this is the line, transmission line, and the power is supplied to the motor. So basically we have 5 components in a power system here. So generator, transformer 1, transmission line, transformer 2 and motor. So all these 5 components are making a power system. So for these power systems, we are going to find the new value of impedances. But as I told you earlier, for the given power system, the old values of impedance values should be given, right? And also the ratings of the components should also be given. So once the ratings of the components and the old values of impedance are given, we can calculate the new values of impedances for all the components. So for this, it is given here. So generator is given. So generator it is given. You know, for any component we should know 3 parameters actually. So the first parameter we have to know is power, and the second parameter voltage, and then third parameter reactance, or we can also have impedance. Both are same. Either impedance or reactance should be given. So these 3 parameters should be given for all the components. So similarly, if you take the power generator 1, so it is given as 60 MVA, this is the power, and 20 kV, this is the voltage, and the reactance value is given as some transient reactance, it is given as 9%. So for the generator, it is given as 3 parameters: power, voltage and reactance. And similarly for transformer 1, it is given. So transformer 1, the power is given as 50 MVA, and then the voltage is given as 20 bar 200 kV. So 20 bar 200 kV is nothing but 20 is the low voltage side, 200 is the high voltage side. So this is step up transformer. So as you studied earlier that for any power system, the transformer which is connected next to the generator is a power transformer or step up transformer. So here we can see here transformer 1 is a step up transformer, so that the 20 kilovolt is stepped up to 200 kV. And also for the transformer, the reactance value is given as 10%. And similarly third parameter or third component, transformer 2. Again for the transformer 2, the power is given as 50 MVA, and then the voltage is 200 bar 20 kV. So 200 is the low voltage side, 20 is the high voltage side. Okay, so here we can see here the transformer is step down transformer. So 200 bar 20, and also the reactance value is given as 10%. And the next component is motor. Whose power is given as 43.2 MVA. The power is given, and then the voltage is given as 18 kilovolt, and then the reactance value is 8%. And last one is the transmission line. So for the transmission line, the power is not given. Power should not be given. So only the voltage is given. It is given as 200 kV. And then for the transmission line, the impedance value is given here. It is 120 plus J200 ohms. Okay, so all the parameters are given. So here you are asked to draw the impedance diagram showing all the impedances in per unit, right, on 100 MVA base, 100 MVA base, and also choose 20 kV as the base voltage for the generator. So normally all these reactances given in the problem, all the reactances for all the components, so that those reactances were calculated using some other base. Now we are going to change the base, and then the base is considered as base power is taken as 100 MVA, base voltage should be taken as 20 kV. So we have to take the base values. So base values nothing but the new values of bases. So the power is given as, new value of power is given as 100 MVA. This is a new power. And then voltage, it is given as 20 kV. 20 kV. So all the power and voltage given in the problem for the parameters, those values are old values. And what you are asked to consider, and what power and voltage, new power and voltage, to be considered is taken as new values. So new power is 100 MVA, new voltage is 20 kV. So using this, we are going to find the Z per unit or reactance value, new values of reactances in per unit. Okay, so we will take the problems one by one. So first, I will take the generator. So for the given power system, initially I am going to take the reactance value. I am going to find the reactance value for the generator. Okay. So as I told you earlier, for a generator, this is the formula to find the new value of Z. Okay. Z per unit new is equal to Z per unit volt, and then kVb volt by kVb new whole square by MVAb new by MAb volt. So this is the formula, correct? So what is new value? What is the old value? What are the new values? What are the old values? So first, step number 1, we are going to consider generator. We are going to consider the generator. For this generator, we are going to find the new values. So before using this formula, you just write the values, old values and the new values, old values and new values. So what are the values we require? We should know what is old power, we should know what is voltage, we should know what is reactance value. What is the old power, what is the old voltage, what is the old reactance. And similarly, we should know what is the new power, new voltage and the new reactance. So for this problem, what is the meaning for old? Old values are nothing but the values given in the problem. So those values are given as old values. And the new value is nothing but what you are asked to consider, what power you are asked to consider, what voltage you are asked to consider, right? So those are called as new values, correct? So if we take the generator, the values are given. Power is given as 60 megawatt MVA, and the voltage is given as 20 kV. The reactance is given as 9%. So 9% is nothing but 9 by 100. Okay, so 9 by 100. So it is 0.09. So percentage is considered as per unit value. Okay, so these are all old values. And a new value. So new value is nothing but what you are asked to consider. So for this, the base values are given. Base values are given. So base value of power, it is given as 100, and voltage it is given as 20 kV. So those values are new values. So new value of power is 100, new value of voltage is 20. And what is the new X value or reactance value? Okay, now we are going to find, or is Z value or X value, both are same, right? So I'll write it here, X per unit new. I'm going to find the new value. So this one I need to find. So this one I need to find. So what is the formula? X per unit volt. What is the X value of volt? It is J 0.9. So it is J 0.09. So that is the old value multiplied by. So as per the formula, what is given? KVB old. What is the old value? It is 20. And what is the new value of voltage? It is also 20 whole square multiplied by. What is this? MVB new power. What is new power? It is 100. New power is 100. And then old power is 60. So just I substituted all the values, new value and old value. Okay. So after calculating, this value is coming around J 0.15 per unit. So this is the new per unit value for the generator. So you can see here, old value is 0.09, new value is 0.15. Right. Now we calculated the value for new value of reactance for generator. And you should understand something, that the power is, base power is taken as 100, or this is nothing but new power. The new power is common for all the components. When you take generator, new power is 100. When you take transformer, new power is 100. When you take transmission line, new power is 100. For this transformer T2, 100. For motor, 100. So for all the components, the new value of power is 100. But whenever the transformer comes, the voltage, new value of voltage is going to be changed. The new value of voltage is going to be changed. For instance, if we take the generator, the new value of voltage is 20 kV. The new value of voltage is 20 kV. So this new value of voltage will be available up to the primary of the transformer. So for generator, 20 kV, new value of voltage is 20 kV. For transformer primary, up to primary, it is 20 kV. But when you consider the secondary of the transformer, the voltage is going to be changed. Understand? So the voltage is available up to primary of the transformer. Once when you go for secondary of the transformer, the value is getting changed. Right? But the power is not going to be changed. New power is not going to be changed. So it is common. 100 MVA, it is common for all. The new value of power is common for all the components. But old value differs. Old value is given the problem, that is different. Understand? So mind that. So now we completed finding the reactance value for the generator. Now we are going to take transformer. So when you take the voltage, new value of voltage, so it is, as I told you earlier, it is 20 kV. So the 20 kV is available up to primary. Right. Now for calculating the reactance value, new reactance value for the transformer, we have to consider the primary of transformer. Understand? We should not consider secondary. So for generator we calculated, for transformer we have to consider primary only, not secondary. Right. So for this case, we have to write what are the old values and what are the new values. So we should know what is power, what is voltage, what is X value. Right. So when you take the transformer 1, the old power is 50 MVA. This is given in problem, and the voltage is 20 bar 200 kV. And then reactance value, it is given as 10%. So it is J 0.1. And the new value, as I told you earlier, new value of power is 100, because this is what we considered. And the new value of voltage is not going to be changed, it is 20. What is the X value? Okay, so as I told you earlier, up to transformer 1 primary, the new value is 20. Understand? So for secondary it is going to be changed. Now we are not going to consider that. So we are going to consider only primary side. So it is 20 kV. Now we can use this formula. Now X per unit new is equal to use this formula, X per unit volt. So what is the volt value of X? It is J 0.1. 0.1 multiplied by what is the old value of voltage? It is 20. What is the new value of voltage? It is also 20 whole square multiplied by what is the new power? New power is 100 always. What is the old power? It is 50. So old values, those values are given in the problem. Okay, so when you multiply all these values, we can have the value as J 0.2 per unit. So this is for transformer. Now, so you can see here the generator we calculated. The generator is connected to the transformer. So we calculate up to primary. Right. Now the third point, we are going to consider the value of line. What is the reactance value for the line? But you can see the transmission line is connected to the secondary of T1. Secondary. Whenever we consider secondary of the transformer, the voltage is going to be changed. So up to primary only, this 20 kV new value of voltage will be available. When you come to the secondary of the transformer, it is going to be changed. And also for transmission line, the impedance value, it is given as 120 plus J 200. So that is given. Okay. So using these values and using new value of voltage, we are going to calculate the impedance value for the transmission line. Right. So for transmission line, you can see here this is the formula. Z per unit is equal to Z actual by Z base. For this case, the Z actual value, it is given as 120. It is given in the problem 120 plus J 200 ohms. Right. And also, what is the new power? New power, as I told you earlier, new power is not going to be changed. It is 100 MVA. For any component, the new power is not going to be changed. But new voltage, it is going to be changed. New voltage. So it is changing now. Up to from generator up to this transformer 1, it is 20 kilovolt. But when you consider the secondary of the transformer, because the secondary is connected to the transmission line, the voltage is going to be changed. Now you can see here the power is transported from low voltage to high voltage. Right. So whenever the power is transported from low voltage to high voltage, we have the formula for finding the new value of voltage. So what is the new value of voltage? Now we are going to find the voltage here. So we are going to find the voltage here. What is the voltage? So this is nothing but new voltage. So that we will be taking as kVb new. Actually we are going to calculate Z value. Before calculating the Z value, new Z value, we have to find the kVb value, because you can see here in the formula it is given as kVb. This is nothing but new value. We are going to find the new value. So it is nothing but kVb old multiplied by this one is HT rating by LT rating. So this is the formula to find the voltage first. Right. So kVb volt is nothing but what is the voltage available at the primary. What is the voltage? The kVb volt here, it is nothing but voltage at primary side, that is the old voltage. So what is the voltage at the primary side? It is 20 kV multiplied by what is the rating of transformer. So if you take the rating of transformer, primary side voltage is 20, secondary side voltage is 200. So what is given the problem? HT rating by LT rating. So HT rating is 200, so it is 200 by LT rating is 20, so which comes around 200. So kVb new it is given as 200 kV. Now we have to use this value in this area. So in order to find the Z per unit value for the transmission line, so I am taking X per unit new for the transmission line, which is equal to X actual, it is given as 120 plus J200 by, you can see here the formula kVb new is 200. So 200 square multiplied by MVAB is new is 100. So when you calculate this value, this comes around 0.3 plus J 0.5 per unit. So this is how we have to calculate the new value of reactance for the transverse line. And what is the new value of voltage calculated here? It is 200 volt, 200 kV. This 200 kilovolt is available up to the primary of transformer 2, up to the primary of transformer 2. So this is nothing but new voltage. Understand? So you can see here the new voltage initially appeared from generator to primary of the transformer 1, and after that we calculated new value of voltage. That new value of voltage will be available from the secondary of first transformer up to primary of second transformer. So up to this case. Right. Now generator is calculated, transformer 1 is finished, transverse line is also over. Now we are going to find what is the value for the transformer 2. Okay, right. Again for transformer 2. Again for transformer 2 we are going to calculate. So for transformer 2, what is the old value? What is the new value? What is the new value? What is the old value? Okay, so what is power? What is voltage? And what is X? Old value, as I told you earlier, it is given the problem. For transformer 2, the power is given as 50. And then the voltage, it is given as 200 bar 20. And X value it is given as 10%, it is J 0.1. And new power is 100. New power is 100. What is the new voltage? Earlier we calculated. It is calculated as 200. So this 200 should be written here. So this is 200 volt. And what is this value? New value of reactance. So X per unit new is equal to what is the formula? As per formula, X per unit volt. So what is the volt value of Z? It is 0.1 multiplied by what is kVb volt? Volt it is given as 200. What is new value of voltage? It is 200 multiplied by, this is square, this much square. And what is the power here? Power new is 100. What is the power volt? It is 50. Okay, great. So when you calculate these values, so this comes around J 0.2. J 0.2. So this is the value we calculated for transformer. Right. Now we calculated the value for up to primary of transformer. So from here to here, the voltage is 20. From here to here, the voltage is 200. Now the transformer comes. So if you consider the secondary, the motor is connected to the secondary of transformer. So if you are going to calculate the reactance value for the motor, we have to take the secondary voltage, new value of voltage for the secondary side. But for all the cases, the power is constant. The power, so the power from here up to motor, it is 100. Up to motor, it is 100. But the voltage is changing. So here up to this transformer, the voltage is 20. From secondary of T1 to primary of T2, it is 200. Now we are going to find what is the new value of voltage. Right. So we will take motor now. So motor. So in order to find the motor, we already know that the voltage up to this point, up to primary of this transformer, it is 200 kV. But we need what is the voltage here? What is the voltage here? Right. So in order to find the voltage here, initially I need to find what is the new voltage, kVb new. In order to find the kVb new voltage, we have to take the previous voltage. So kVb volt multiplied by the rating of transformer. So if we take the rating of transformer, this is step down transformer, So this is 200 volt, 200 kV, this is 20 kV. So it should be written as 20 by 200. 20 by 200. So we can take the new value of voltage as 20 kV. So what is the voltage here? This voltage from secondary of the transformer up to the motor, the voltage is 20 kV. This is new voltage. This is new voltage. But as I told you earlier, the power is constant. The power is 100. Right. So for motor, we will take the values old value and new value. Old value and new value. So what is the power for the motor? The power for the motor, it is given as 43.2. 43.2. What is the old voltage for the motor? It is given as 18 kV. What is X value? It is given as 8%. It is J 0.08. And similarly, what is the new value? As I told you earlier, it is 100 always. What is the old value of what is the old new value of the motor? It is 20. We calculated now. Okay, so now we calculate 20. And what is the new X value? We are going to find. So now X per unit new is equal to X per unit new is equal to old value, it is J 0.08 multiplied by the voltage old by new square. What is the old voltage? It is 18 by new value is 20 whole square, 20 square multiplied by the new power, it is 100, the old power, it is 43.2. 43.2. So once it is calculated, the value is coming around J 0.15. J 0.15 per unit. So for all the components, we calculated, the X per unit values. Now we are going to draw the reactance diagram. So while using all these values, we are going to draw the reactance diagram. So for drawing the reactance diagram, you know that the generator and motor that should be connected in parallel and other things that should be connected in series, right? So if you take the generator, the reactance diagram for the generator, it is represented as like this. So this is generator reactance diagram. Okay, so this is your generator 1, this is your reactance diagram, this is X value. So X value we calculated as J 0.15. Right, generator is over. And when you take the transformer should be connected in series. So this is the reactance diagram for the generator transformer. So this is for reactance value for transformer 1. So what is the value? We calculate as J 0.2. J 0.2. And we are having the transmission line. So the transmission line is, the value is given like this. So this is X transmission line. Transmission line. So the value we calculated as 0.3 plus J 0.5. So transformer, transmission line, those things should be connected in series. So this is transformer 1, this is transmission line, and again transformer 2 is here. So this is your transformer 2, reactance value for transformer 2, we calculate as J 0.2. J 0.2. And lastly, we have motor, the motor should be connected in parallel, then the reactance value should be connected like this. So this is motor. So the value for motor we calculated as 0.15. So joining all these, so we have drawn the reactance diagram for the given power system. But we considered the new base and we calculated the reactance values for all the components, 5 components, and we had drawn the diagram, reactance diagram. I hope you can understand.